So what is up, guys? Today we're going to be discussing the concepts of imaginary numbers. And what imaginary numbers are numbers that the square root is zero, or the square root is a negative number. And so an imaginary number is the square root of negative 1, and we call it I. So I is the square root of negative 1. That can never change. That is set in stone and in concrete. So the origins of imaginary numbers came to be is people always knew that a positive times positive gave you a positive. Negative times a negative still gave you a positive. That was generally accepted. So somebody came along and thought, what would I need to multiply times itself to give me a negative? So in the spirit of imaginary numbers, we're going to take this I right here. We're going to make a lowercase I. So I times I, and we want to get a negative number. We're just going to use negative 1. So I squared equals negative 1. Take the square root of both sides, and you get I equals square root of negative 1. What does that look like? That right back over there. So that's how we came about to getting I as the accepted value of the square root of negative 1. And so I is used in a lot of places, and we'll start with complex numbers. Now, complex numbers are a combination of regular integers and imaginary numbers. And the standard form is A plus B times I. So complex number example will be 3 plus 5I. Now, don't think that because that says so, we can do 8I. Because 3 plus 5 times the square root of negative 1 is very different from 8 times the square root of negative 1. This I functions similarly to an x. Unless they are being multiplied together, or they both have the coefficient I, cannot work. Now, if this were to be 3I plus 5I, by all means, boom. But if it's no 3I, then this does not work. Because this is very different from this. These are not interchangeable. These cannot be swapped out for each other. Alright, so complex numbers, you've got to remember that the I, the big key you have to take away from this is that the I functions similarly to an x. You cannot combine unless they both have an I raised to the same power. Okay, so we've covered complex numbers. Now, surprisingly, imaginary numbers are also used in electricity. You might be thinking, what? Electricity, how are they used in that? Well, when you're using current, and current is lowercase I already, so imaginary numbers here are J, just to prevent confusion. When you're using current, whenever, more specifically alternating current, it can fluctuate between positive and negative, and that produces a sine wave. Well, of course, you know that if they were to do some figuring, try to figure out, we have sine wave 1, sine wave 2. Well, they try to figure out what those currents are together. You know that somehow, some way, there's going to be a negative, square root of a negative in there. So by using complex numbers in there, they are able to figure out the overall current very easily. They're able to figure out whatever I is by using, in their case, J, because again, I is already current, and they don't want to be confused and be thinking that the current is equal to the square root of negative 1. So they just threw in J because J is right after I, and it's very close and it's easy to remember. So anyways, it can be used in complex numbers and electricity. So those are two places it can be used, but it can also be used elsewhere. It can be used in quadratic equations. solutions. And quadratic equation is standard form ax squared plus b of x plus c equals 0. Big key right there. It's got to equal 0. It's not going to work otherwise. So these solutions can end up being imaginary numbers. And generally in some classes, unless you're dealing with something that really enjoys imaginary numbers, you're going to be generally looking for the real solutions. So real solutions have no I. Real solutions have no I. No I is used in a real solution. But sometimes you may be asked for all solutions. So that would include 1, 2, 2i, 17i, and so forth like that. So some solutions can be imaginary, and that's okay. It just means that they're not a real number on the real coordinate plane. So if you're going to pull up a regular coordinate plane, you know that you've got your x's and your y's. Y is an x. Well, there's no room for imaginary numbers. So we have to make a special coordinate plane where this is your y-axis and this is your x-axis. And so then we can start putting in some imaginary numbers. So this is what you want to use for imaginary numbers. This is for real numbers. So in imaginary numbers, if you were to do the square root of negative 17, well, you can't just say that's I, because I equals square root of negative 1. So what you would need to do is figure out, separate it into square root of negative 1 and square root of 17. You know square root, we don't know what square root of 17 is, so we'll just toss this and say it's square root of negative 16. So we know square root of 16 is 4. So this is going to end up being 4 on the square root of negative 1, or 4i. So the square root of negative 16 is going to be 4i, because we have the square root of 6. Because if we were to factor out 16, we go 16, we go 4, 4, all kinds of, you get 4 2's from that. Alright, so you know a square root, little trick, pair up the 2's because of this 2 on the outside. So 2, 2. So these become 2 2's on the outside. So you get 2 times 2 on the square root of negative 1. So 4 square root of negative 1, 4i. So boom. That's a little lesson, real quick lesson for you. So anytime it's a number larger than 1, factor it out and then figure out what your pairs would be, because generally you're looking for the square root of something. And you'll be able to transform it into sort of a complex number, because this complex number is saying 0 plus 4i, so we just don't even worry about that part and just focus on 4i. So we've just kind of made a complex number right here. Now, there's a cycle of I. So you know I equals square root of negative 1. What about I squared? That's square root of negative 1 times square root of negative 1. Those square roots will cancel, so you get negative 1. What about I cubed? Well, that's going to be negative 1 times square root of negative 1. So you're going to get negative square root of negative 1. And you know square root of negative 1 is I, so you'll get negative I. And then I to the 4. And square root of negative 1 up here is, as we all know, I. Well, what about I to the 4? I to the 4 is going to be I to the 2 dot I to the 2. So negative 1 times negative 1 equals positive 1. So it's a real big cycle of I, negative 1, negative I, 1. And it keeps going over and over and over again to infinity. And if you guys want to check out imaginary numbers, you should definitely research